Look up at the night sky, past the familiar twinkle of stars, and you might catch a glimpse of something far more mysterious, a faint, glowing cloud suspended in the darkness. That's the Orion Nebula, a celestial masterpiece where cosmic dust and gas swirl in vibrant hues of pink, blue, and gold. For centuries, this breathtaking sight has captivated not just astronomers but poets, painters, and dreamers, each seeing something different in its shimmering depths. To scientists, it's a stellar nursery, a place where gravity weaves together the raw materials of the universe to birth new stars. To artists, it's a canvas painted by the cosmos itself, a reminder that beauty and discovery are forever intertwined. But what if these two perspectives, science and art, aren't as separate as they seem? What if the stories we tell about nebulae, the images we create, and the questions we ask all lead us closer to understanding the universe in ways we never expected? This is where the magic happens. Nebulae aren't just distant clouds of gas. They're the cradles of creation, the workshops where stars are forged from chaos. Imagine the forces at work here: gravity pulling, gases colliding, temperatures soaring to millions of degrees, all to ignite the spark of a new sun. And yet, for all the precision of astrophysics, there's something profoundly artistic about this process. The same nebula that inspires equations and data also inspires symphonies and sculptures. It's as if the universe is reminding us that discovery isn't just about numbers, it's about wonder. So today, we're setting off on a journey to explore these cosmic wonders from both sides of the lens. We'll dive into the science of star birth, unraveling how gravity and chemistry conspire to create light in the void. But we'll also step into the world of art, where nebulae become metaphors, muses, and mirrors of our own curiosity. Because when we study the birth of stars, we're not just learning about distant galaxies, we're learning about ourselves. How do we make sense of the infinite? How does beauty guide our search for truth? And what can these swirling clouds of gas teach us about the universe and our place within it? The answers might surprise you, so let's begin. Long before telescopes revealed the true nature of nebulae, these cosmic clouds danced through human imagination as something far more mystical. The ancient Greeks saw them as the scattered breath of God's ethereal signs etched across the heavens. To the Chinese astronomers of the Han Dynasty, they were celestial brushstrokes, heavenly inkblots hinting at the harmony between earth and sky. Even the word nebula itself comes from the Latin for mist or cloud, a testament to how early stargazers tried to make sense of these hazy patches of light. What's remarkable isn't just how wrong they were by modern standards, but how right they were in another way. These cultures, separated by continents and centuries, all sensed something profound in those shimmering veils, a connection between the cosmos and the human spirit. By the 17th century, the invention of the telescope began to peel back the layers of mystery. Astronomers like Charles Messier meticulously catalogued these fuzzy objects, not out of artistic fascination, but to avoid confusing them with comets, celestial roadmaps for the scientifically curious. Yet even then, the allure of nebulae refused to be reduced to cold observation. William Herschel, who discovered Uranus, famously described the Orion Nebula as an unformed fiery mist, the chaotic material of future suns. Science was beginning to explain the how, but the why, the sheer emotional pull of these structures remained as vivid as ever. Today, we understand nebulae as stellar nurseries, where hydrogen and dust collapse under gravity's relentless pull until nuclear fusion ignites a new star. The science is precise, measurable, yet no less wondrous. Modern telescopes like Hubble and Webb have transformed these cosmic clouds into high-definition masterpieces, revealing details that would have left ancient astronomers breathless. But here's the beautiful paradox. The more we've demystified nebulae, the more they've inspired us. Artists render them in swirling oils, musicians compose symphonies to their rhythms, and poets still find metaphors in their light. Science tells us how stars are born, but art reminds us why it matters, because in tracing the life cycle of a nebula, we're also tracing our own endless curiosity. The same questions that haunted the Greeks now drive our space telescopes. What's out there? What does it mean? And how do we fit into this vast starry tapestry? The answers, it seems, are written in the nebulae themselves, not just in their chemistry, but in their ability to bridge the gap between calculation and wonder. At their core, nebulae are cosmic cauldrons where the raw ingredients of stars simmer in swirling clouds of hydrogen and helium, the same elements that fuel the sun's fiery heart. These molecular clouds, as scientists call them, are staggeringly vast, often stretching light years across, yet they're delicate enough that a single nudge from gravity can set off a chain reaction of creation. Picture the pillars of creation in the Eagle Nebula, those towering columns of dust immortalized by the Hubble Space Telescope. What looks like a frozen sculpture is actually a frenetic construction site, where pockets of gas collapse under their own weight, heating up until atoms fuse and a star flickers to life. Astrophysicist Carl Sagan once described this process as the universe's way of recycling itself, turning the ashes of dead stars into new celestial beacons. But here's where science and art collide in the most unexpected ways. Long before telescopes could peer into the heart of a nebula, painters and poets sensed their dynamism. Take the swirling brushstrokes of Vincent van Gogh's Starry Night. Its turbulent skies mirror the chaotic beauty of star-forming regions, even though Van Gogh never saw a nebula up close. Or consider the works of contemporary artists like Lynette Cook, who translates astrophysics data into luminous paintings, her colors echoing the infrared glow of distant gas clouds captured by the James Webb Space Telescope. These creators aren't just illustrating science, they're reimagining it, asking questions that equations alone can't answer. What does it feel like to witness a star's birth? How do we convey the scale of something both unimaginably massive and intricately detailed? This interplay between discovery and creativity reveals something profound. Our understanding of nebulae isn't just shaped by equations and telescopes, but by the human impulse to find meaning in the unknown. When scientists map the magnetic fields of a nebula or calculate the exact moment fusion ignites, they're uncovering truths about the universe's mechanics. But when an artist renders those same forces in vivid hues, or a composer turns stellar vibrations into music, they're uncovering truths about us, our awe, our curiosity, our need to connect with the cosmos. The pillars of creation aren't just a laboratory for physics, they're a mirror reflecting our endless drive to explore, whether through the lens of a telescope or the stroke of a brush. And perhaps that's the real magic of nebulae. They remind us that every scientific revelation is also a story waiting to be told, a canvas waiting to be painted, a symphony waiting to be heard. Long before the Hubble Space Telescope gifted us with its breathtaking portraits of nebulae, artists were already attempting to capture their elusive beauty with the tools of their time. In the Renaissance, astronomers like Galileo sketched the Orion Nebula as a smudged cluster of stars through crude telescopes, their drawings more scientific record than artistic expression. Yet even these rough outlines carried a sense of reverence, as if the artists sensed they were glimpsing something beyond human scale. Fast forward to the 19th century, and you'll find Etienne Leopold Trouvelot, a French artist-astronomer whose pastel renderings of nebulae blended meticulous observation with an almost romantic sensibility. His depiction of the Great Nebula in Orion, with its delicate wisps of light and shadow, didn't just document celestial phenomena, it invited viewers to feel the vastness of space. What's fascinating is how each era's technology and cultural mindset shaped these artistic interpretations. Trouvelot's soft pastels mirrored the limitations of telescopes in his day. Nebulae appeared as ethereal blurs, encouraging an impressionistic style. Compare that to the sharp, hyper-detailed Hubble images we know today, where every tendril of gas seems to crackle with energy. Modern digital artists, armed with data from infrared telescopes and supercomputer simulations, don't just paint nebulae, they reconstruct them using science as their brush. Take the work of NAS, a visualization team where algorithms transform raw data into swirling, color-saturated vistas art that's as accurate as it is awe-inspiring. But here's the deeper question. Why does art matter in understanding something as scientific as a nebula? Perhaps because it bridges the gap between fact and feeling. A graph of stellar temperatures can tell us how hot a young star burns, but a painting like Trouvelot's or a modern digital rendering makes that heat palpable, almost visceral. Art translates the abstract into the emotional, reminding us that these cosmic clouds aren't just subjects of study, they're stories waiting to be felt. When we gaze at a Hubble image, we're not just seeing hydrogen and dust, we're witnessing the birth of light itself, framed by the same creative impulse that drives both scientists and artists. Today, this interplay between art and science has never been more vibrant. Contemporary creators like Tim Dodd, the everyday astronaut, use 3D modeling to animate nebula formations, while musicians like John D. Boswell compose symphonies using actual stellar vibrations translated into sound. These works don't just illustrate science, they humanize it, inviting us to experience the cosmos not just with our minds but with our hearts. The nebulae haven't changed over the centuries, but how we see them, how we choose to see them, reveals as much about us as it does about the stars. And in that shared act of looking, imagining, and creating, we find something rare, a universe that speaks not just in equations, but in color, music, and wonder. When the Hubble Space Telescope first opened its eye to the cosmos in 1990, it didn't just capture images, it rewrote our visual vocabulary of the universe. Before Hubble, nebulae were little more than faint smudges in even the most powerful ground-based telescopes. But with its crisp, unobstructed view above Earth's atmosphere, Hubble turned those smudges into swirling symphonies of light and color. Take the Crab Nebula, the remnants of a supernova witnessed by Chinese astronomers in 1054. Through Hubble's lens, it became a frenetic web of filaments, each thread glowing with the energy of a dying star's last gasp. Scientists pored over these details to decode the physics of stellar explosions, while the public marveled at a cosmic work of art. That's the magic of Hubble. It didn't just advance astronomy, it gave the universe a canvas. What's often overlooked is how these images are crafted. Hubble doesn't see color the way we do. It captures light in wavelengths invisible to human eyes, from ultraviolet to near-infrared. The vibrant hues we associate with nebulae are carefully mapped by astronomers, who assign visible colors to different elements. The rich blues might represent oxygen, the fiery reds hydrogen, turning raw data into a visual story. This isn't artistic license, it's a translation. As astrophysicist Dr. Michelle Thaler explains, color is how we make the invisible universe speak to our senses. The iconic pillars of creation, for instance, aren't just a breathtaking backdrop for desktop wallpapers, they're a precise representation of density, temperature, and chemical composition, disguised as a cosmic cathedral. This interplay between science and aesthetics has sparked unexpected collaborations. When Hubble's images began circulating in the 90s, they didn't just fill textbooks, they inspired fashion designers, filmmakers, and even tattoo artists. The Eagle Nebula's ethereal glow found its way onto album covers and runway prints, while the Helix Nebula's eerie symmetry became a muse for digital animators. Astronomers quickly realized these images weren't just tools for research, they were bridges to the public's imagination. Dr. Mario Livio, a former Hubble scientist, recalls how the telescope's photos became ambassadors of science, drawing people into the mysteries of the cosmos through sheer beauty. Now, with the James Webb Space Telescope pushing further into the infrared, we're witnessing a new chapter in this visual revolution. Webb's images of the Carina Nebula reveal structures hidden to Hubble, like cosmic cliffs where stars are born in radiant waves. Yet the core idea remains. Whether it's Hubble's jewel-toned vistas or Webb's gold-filtered landscapes, these telescopes remind us that science and art aren't opposites, they're dialects of the same language. The colors may be translated, but the wonder is universal, and in that shared awe we find something extraordinary, a universe that invites us not just to study, but to stare. Gaze at a nebula through a telescope, and you'll see a haze of gray, a far cry from the vibrant blues and crimsons splashed across magazine covers and screens. So where do those dazzling colors come from? The answer lies in a fascinating dance between science and storytelling. Telescopes like Hubble and Webb capture light in wavelengths our eyes can't see: infrared, ultraviolet, X-rays, and scientists then translate that data into a visual language we can understand. Hydrogen might be mapped as red, sulfur as green, oxygen as blue, turning raw numbers into a cosmic rainbow. This isn't just artistic flair. It's a careful coding system where every hue reveals a secret about the nebula's composition, temperature, and energy. The iconic pillars of creation, for instance, aren't naturally blue and gold. Those colors are a key, telling us where oxygen glows and dust scatters starlight. Yet artists have always taken liberties with color to evoke emotion long before telescopes existed. Van Gogh's Starry Night swirls with cobalt and gold, not because the night sky looked that way in 1889, but because those colors felt true. They captured the turbulence and wonder he saw in the cosmos. Modern creators face a similar choice when interpreting nebula imagery. Should they stick to the scientific palette or amplify hues for dramatic effect? NASA visualizations often walk this line, balancing accuracy with awe. The famous Pillars image, for example, uses enhanced contrast to make the gas structures pop, a decision that sparked debates among purists. Is it misleading to tweak reality, even if it draws more eyes to the science? This tension between true and representational color isn't just academic, it shapes how we connect with the universe. When the James Webb Telescope unveiled its first deep field image, some viewers were startled by the golden-orange galaxies. But those colors weren't arbitrary. They reflected Webb's infrared focus, revealing older, redder stars invisible to Hubble. Scientists could have rendered the same data in cooler blues, but the warm tones emphasized the image's depth and age, making the ancient light feel as old as it truly was. Here, technology doesn't just serve science or art, it bridges them. Advanced software lets astronomers shift palettes with a click, while digital artists use astrophysics data to create hyper-realistic nebulae in films and games. The irony, both fields are chasing the same goal: to make the invisible visible. Whether it's a researcher highlighting ionized helium or a painter exaggerating a nebula's glow, they're guided by the same question: how do we share the universe's grandeur in a way that resonates? Maybe the true color of a nebula isn't the one our eyes would see, but the one that sparks curiosity, whether it's coded by a spectrometer or an artist's brush. After all, every image of space is a translation, and sometimes the most accurate renditions are the ones that remind us to look up in wonder. The James Webb Space Telescope doesn't just observe the cosmos, it reimagines how we see it. With its infrared eyes, Webb peers through cosmic dust like an X-ray machine for the universe, revealing hidden nurseries where stars are born. But the real revolution isn't just in the data, it's in how that data leaps from scientific journals into the hands of artists and storytellers. Take NASA Astrophysical Visualizations Lab, where raw telescope feeds are transformed into swirling, three-dimensional animations. Here, astrophysicists and digital artists work side by side, turning light curves and spectral graphs into immersive journeys through nebulae. One standout project, a virtual fly-through of the Orion Nebula, crafted using Webb's observations, where viewers can glide past newborn stars as if riding a cosmic current. As digital artist Sophie Harker puts it, tools like this don't just illustrate science, they make it visceral. Suddenly, you're not just learning about star formation, you're feeling the scale, the heat, the turbulence. This collaboration thrives on software that blurs the line between lab and studio. Programs like Blender and Unreal Engine, once reserved for game designers, now let scientists sculpt nebula models with particle physics. Artists like Eric Wernquist, known for his photorealistic space scenes, use actual telescope data to ensure every dust cloud and plasma flare aligns with astrophysics. His short film Wanderers, a breathtaking tour of hypothetical exoplanets, feels like a documentary, even though it's speculative, because it's grounded in real orbital mechanics and atmospheric science. Technology lets us cheat time and distance, Wernquist explains. We can't visit the Carina Nebula, but we can build it pixel by pixel, so viewers experience its grandeur firsthand. The impact ripples beyond galleries and YouTube videos. Blockbuster films like Interstellar and The Martian leaned heavily on astrophysics consultants, ensuring their black holes and dust storms mirrored real phenomena. Even video games like Elite Dangerous incorporate star maps from the European Space Agency, letting players navigate a scaled Milky Way with authentic nebulae as backdrops. This cross-pollination does more than entertain, it rewires how we think about space. When a teenager gazes at a nebula in no man's sky, they're not just seeing a pretty backdrop, they're absorbing the fractal complexity of real cosmic structures. Perhaps the most profound shift is in storytelling itself. Nebulae have become characters in modern sci-fi, symbols of mystery and rebirth. In Star Trek, the Mutara Nebula's chaotic gases hid the Enterprise from Khan, its swirling clouds acting as both shield and specter. Guardians of the Galaxy turned the Noha outpost, a city inside a severed celestial head, into a neon-drenched hub of lawlessness, echoing the way real nebulae nurture chaos and creation. These narratives tap into something primal. Nebulae aren't just settings, they're metaphors for the unknown, mirrors of our own curiosity. And as technology tightens the bond between science and art, those metaphors grow richer, more nuanced, reminding us that every pixel, every equation, is part of a story billions of years in the telling. Nebulae have long been the backdrop for humanity's grandest tales, their swirling colors and shadowy depths serving as the ultimate stage for adventure and danger. Think of the Mutara Nebula in Star Trek Roman II, the Wrath of Khan, where Kirk and Spock faced off against a vengeful enemy amid chaotic gas clouds, a setting that turned cosmic dust into a character itself, obscuring senses and heightening tension like a celestial fog. Or consider Star Wars, where nebulae frame epic battles, their vibrant hues contrasting with the cold blackness of space, reminding us that even in the void, there's beauty and unpredictability. These fictional nebulae aren't just pretty scenery, they're narrative devices embodying the unknown and the perilous, much as they did for ancient sailors navigating uncharted seas. But how do these Hollywood versions stack up against reality? The Mutara Nebula's violent electrical storms might be exaggerated, but real nebulae like the Tarantula or Carina are just as turbulent, with stellar winds carving caverns into gas clouds and radiation painting the sky in otherworldly colors. Sci-fi often portrays nebulae as dense, ship-swallowing mazes, yet in truth, most are so diffuse you could fly a starship through one without noticing, until the radiation hit. The irony, while filmmakers amp up the drama, real nebulae are more spectacular than fiction can often capture. The Crab Nebula's pulsar heartbeats or the Horsehead silhouette against stellar nurseries are stranger than any script. Beyond cinema, nebulae haunt the pages of sci-fi literature, from Arthur C. Clarke's 2001 to Anne Leckie's Ancillary Justice, where they symbolize transformation places where characters confront the infinite or shed their old selves. In games like Mass Effect, navigating nebulae becomes a metaphor for exploration, their hazards and hidden planets mirroring the unpredictability of discovery. These stories shape how we perceive space, turning nebulae from distant clouds into cultural touchstones. When a child points to the Orion Nebula and calls it the Star Wars cloud, that's pop culture bridging the gap between imagination and science. And that bridge has a profound psychological effect. Nebulae in stories tap into something primal, the allure of the unexplored, the thrill of stepping into the void. They're cosmic Rorschach tests reflecting our fears and aspirations. In Guardians of the Galaxy, Noah's mining colony inside a severed celestial head turns a nebula into a lawless frontier, echoing humanity's history of venturing into wild places for profit and peril. These narratives don't just entertain, they prepare us in a way for the real frontier. When astronomers today talk about stellar nurseries, the term feels familiar because we've already imagined them as places of birth and danger. The stories we tell about nebulae don't just mirror science, they shape how ready we are to embrace its wonders. There's something almost primal about the way a nebula arrests our attention, how its swirling colors and unfathomable scale trigger a visceral reaction, a catch in the breath. Psychologists call this awe, that humbling, expansive feeling when confronted with something vast beyond comprehension. Studies from the University of California reveal that exposure to cosmic imagery, like Hubble's nebula portraits, doesn't just inspire wonder, it rewires our perspective, making people feel smaller yet more connected to something greater. Participants in these experiments reported heightened curiosity, even a renewed sense of purpose, as if glimpsing the cosmos had quietly recalibrated their place within it. Astronauts described this sensation with uncanny similarity. When Chris Hadfield gazed out the International Space Station's cupola, he didn't just see the Orion Nebula as a scientific marvel, he felt it as a presence. It's like staring into a cathedral of light, he recalled, where you're simultaneously insignificant and part of everything. That duality, the tension between humility and belonging, lies at the heart of why nebulae captivate us. They're mirrors reflecting our deepest questions. Where do we come from? Why are we here? Ancient cultures projected myths onto these cosmic clouds, but modern science reveals an even more astonishing truth: the atoms in our bodies were forged in stellar nurseries like these. We're not just observers of nebulae, we're their descendants. This emotional resonance fuels humanity's twin engines of exploration and creativity. The same awe that drives astronomers to map a nebula's magnetic fields compels poets to liken its glow to a symphony of silence. It's no coincidence that Carl Sagan's pale blue dot or the photography of the Hubble Heritage Project strike such universal chords. They tap into a shared longing to make sense of the infinite. Even children, handed crayons to draw space, instinctively swirl blues and purples into nebula-like shapes, as if the urge to recreate cosmic beauty is wired into us. Yet beneath this wonder lies a relentless scientific pursuit. Every Hubble image of the Orion Nebula's star-birthing cliffs, every Webb snapshot of the pillars of creation, isn't just art, it's data. Astronomers peer into these clouds not just to admire their beauty, but to decode the physics of creation itself. How does gravity sculpt gas into stars? What determines whether a nebula births a humble red dwarf or a brilliant blue giant? These questions aren't abstract, they're pieces of a puzzle that traces back to our own origins. The iron in our blood, the calcium in our bones, all were forged in stellar furnaces and scattered across space by nebulae like these. So when we stare into the Orion Nebula's glow, we're not just witnessing the birth of stars. We're glimpsing our own cosmic lineage, written in light and gas. And perhaps that's the most profound awe of all, realizing that to study the universe is, in a way, to study ourselves. Deep within the swirling chaos of a nebula, hidden behind veils of dust and gas, an extraordinary transformation unfolds, one that turns scattered atoms into blazing suns. The journey begins with something deceptively simple: gravity. Imagine a single speck of dust drifting in the void for millions of years until one day it brushes against a neighboring particle. Slowly, almost imperceptibly, their mutual pull draws them closer. More particles join, clustering together like cosmic snowflakes in a silent storm. This is the birth of a protostar, a stellar embryo wrapped in a cocoon of gas. For now, it's cold and dark, but deep inside, pressures are mounting. As gravity continues its relentless work, the protostar's core becomes a cosmic pressure cooker. Gas and dust spiral inward, colliding and compressing until temperatures soar to unimaginable heights, millions of degrees. Here's where the magic happens. When the core reaches around 10 million degrees Celsius, hydrogen atoms, once separate, slam together with such force that they fuse into helium. This is nuclear fusion, the same process that powers our sun, and it unleashes a torrent of energy. Suddenly, the protostar isn't just a collapsing cloud. It's a star, igniting with a brilliance that can outshine entire galaxies. But not all stellar births follow this script. Recent discoveries have revealed rogue planets, worlds untethered to any star, forming alone in the darkness of isolated nebulae. These cosmic orphans challenge our understanding of star formation, proving that even in the coldest, loneliest corners of space, gravity finds a way to create. Telescopes like ALMA have captured eerie, ring-shaped structures around these rogue worlds, hinting at miniature versions of the same processes that build stars. It's as if the universe is whispering, there's more than one path to creation. Observing these stages isn't easy. Nebulae cloak their secrets in dust, and the birth of a star can span millions of years, a timescale that dwarfs human observation. Scientists piece together the story like detectives, using infrared telescopes to peer through obscuring dust or radio waves to map the faint whispers of collapsing gas. Each new observation, whether it's a fledgling protostar in Orion or a rogue planet drifting through the Ophiuchus Nebula, adds another piece to the puzzle. And with every discovery, we're reminded, the birth of a star isn't just a scientific process, it's a cosmic epic, written in gravity, light, and time. If you've ever tried to look through a foggy window, you know how frustrating it can be. The world outside reduced to blurry shapes, details swallowed by the haze. Nebulae present a similar challenge to astronomers. their star-forming regions shrouded in thick veils of dust that visible light simply can't penetrate. But where our eyes fail, infrared astronomy steps in, acting like a cosmic pair of night vision goggles. Telescopes like the James Webb Space Telescope don't just see through these dust clouds, they reveal an entirely hidden universe within them. Compare a visible light image of the Orion Nebula, where towering pillars of gas appear as faint silhouettes, to Webb's infrared version, and it's like flipping on a light switch. Suddenly, those dark pillars erupt with newborn stars, their heat signatures glowing like embers in the cosmic dark. This isn't just a technical trick, it's a revolution in how we understand star birth. Infrared light, with its longer wavelengths, slips between dust particles like a whisper through a crowded room, exposing the nurseries where stars are cradled. Dr. Heidi Hammel, a planetary astronomer, describes it as peeling back the universe's wrapping paper. Where Hubble's visible light images showed the Orion Nebula as a majestic but static landscape, Webb's infrared vision unveiled a dynamic construction zone. Jets of material shooting from infant stars, cavities carved by stellar winds, and molecules like water and carbon dioxide clinging to dust grains. These are the ingredients of planetary systems, and for the first time, we're watching them assemble in real time. The contrast between these wavelengths isn't just scientific, it's artistic. Visible light images, with their ethereal blues and pinks, often feel like celestial watercolors, while infrared views resemble molten gold, warmer, richer, alive with hidden energy. Artists have seized on this duality, creating hybrid interpretations that blend the two perspectives. Digital illustrator Judy Schmidt, known for her processing of Hubble and Webb data, layers infrared and visible light observations to produce works that are both scientifically accurate and hauntingly beautiful. Infrared doesn't just show us what's hidden, she explains. It forces us to rethink what color even means in space. This interplay between revelation and artistry raises a fascinating question. How do you depict something invisible to human eyes? Composers like Sophie Kastner have turned infrared data into music, assigning pitches to different wavelengths, so the pillars of creation sing in eerie, resonant tones. Meanwhile, installations like NASA's Universe of Sound project let visitors feel nebula vibrations through haptic feedback. These creations aren't just novelties, they're bridges, translating the language of photons into something our senses can grasp. When we listen to a nebula's song or trace its heat patterns with our fingertips, we're not just observing the cosmos, we're experiencing it one wavelength at a time. Long before telescopes could resolve the swirling depths of the Orion Nebula, artists were already channeling its chaos onto canvas, not with precise brushstrokes, but with wild, untamed splashes of color that seemed to defy logic. Take Wassily Kandinsky, the father of abstract art, whose explosive compositions in the early 20th century, like Composition 8 with its intersecting arcs and vibrant planes, uncannily echoed the turbulent energy of star-forming regions. At the time, astronomers barely understood nebulae as more than fuzzy patches, yet Kandinsky's work captured their essence instinctively. He famously described art as the echo of the cosmic, a sentiment that feels prophetic now that we know nebulae aren't serene clouds, but violent cradles where magnetic fields twist and stellar winds scream at millions of kilometers per hour. This synergy between abstraction and astronomy has only deepened with time. Modern installations like Rafik Anadol's machine hallucinations use AI to transform telescope data into immersive, ever-shifting nebulae of light and sound, where visitors walk through corridors of synthesized stardust. Anadol doesn't just depict space, he reconstructs its unpredictability. letting algorithms reinterpret Hubble datasets into forms that even scientists couldn't anticipate. It's a fitting parallel to how real nebulae behave, governed by physics, yet brimming with patterns too complex to predict. As astrophysicist Jana Levin notes, the universe is the ultimate abstract artist, painting with math we're still learning to read. What's striking is how both art and science grapple with the unknown. Abstract expressionists like Jackson Pollock embraced chaos, dripping paint in rhythms that mirrored cosmic turbulence. His number one could easily be a snapshot of the Tarantula Nebula's tangled filaments. Similarly, quantum physics reveals that at subatomic levels, certainty dissolves into probability clouds, not unlike the haze of a nebula's edge. This shared tension between order and randomness fuels both fields. When artist Julie Meritou layers architectural sketches with explosive marks in her murals, she's not just echoing celestial collisions, she's tapping into the same existential curiosity that drives astronomers to map dark matter. Cultural narratives have long woven nebulae into myths of creation and destruction, from Polynesian legends where they're the scattered bones of deities to Navajo cosmology, framing them as celestial sand paintings. Today, that storytelling continues in unexpected ways. The Nebula Music Festival in Iceland projects real-time auroras alongside synthesized nebula visuals, merging Earth's atmospherics with cosmic grandeur. Video games like Destiny render nebulae as mystical gateways, while poets like Tracy K. Smith write of them as the breath of ancestors still glowing. These interpretations aren't mere fantasy. They're proof that nebulae transcend data. They're mirrors, sometimes literal, as with the Helix Nebula's eerie eye-like structure, reflecting our endless need to find meaning in the beautiful, bewildering chaos of the cosmos. To the Maori people of New Zealand, the Magellanic Clouds, those two hazy patches of light near the Milky Way aren't just random gas clouds. They're the sails of a celestial waka, a great canoe carrying the spirits of ancestors across the night sky. This myth, passed down through generations, transforms a nebula from an astronomical object into a vessel of cultural memory. Meanwhile, halfway across the world, a sci-fi fan watching Star Trek might see those same clouds as the Mutara Nebula, a treacherous battlefield for starships. These two perspectives, one rooted in ancestral wisdom, the other in futuristic fantasy, reveal how nebulae straddle time, serving as both ancient storytellers and blank slates for tomorrow's myths. What's striking is how these narratives converge. The Maori waka and Star Trek's nebula both frame these cosmic structures as thresholds, places of transformation where ordinary rules don't apply. Indigenous stories often depict nebulae as liminal spaces where the physical and spiritual worlds intersect. The Navajo, for instance, see the Orion Nebula as a cosmic forge where the black god stamped the constellations into existence. Compare that to modern sci-fi, where nebulae function as narrative turning points. In Battlestar Galactica, the Tylium Nebula hides resources essential for survival, while in Doctor Who, the Castorborous Nebula marks the pivotal return to the protagonist's home planet. Whether sacred or speculative, these stories share a common thread. Nebulae aren't just scenery, they're catalysts. This cultural tapestry is expanding as underrepresented voices reshape cosmic storytelling. Authors like Rebecca Roanhorse weave Navajo cosmology into her Between Earth and Sky series, where nebulae are living entities with agency. The video game Never Alone, developed with Alaska Native elders, reimagines the Aurora Borealis as a pathway for spirits, blending science with Inupiat tradition. Even blockbusters are catching on. Thor, Love and Thunder briefly showcased Aboriginal Australian sky lore, hinting at a richer, more inclusive universe. These narratives do more than diversify sci-fi. they challenge the Western trope of nebulae as mere hazards or backdrops, inviting us to see them as teachers, guides, or even kin. Yet this creative freedom raises ethical questions. When Hubble's images of the Eagle Nebula became iconic, few asked who owned their beauty. But as artists and filmmakers mine indigenous cosmologies for inspiration, lines blur between homage and appropriation. The Maori have fought to protect their star lore from commercial exploitation, while NASA collaborates with native Hawaiian scholars to ensure telescope projects on Mauna Kea respect sacred land. Perhaps the next frontier isn't just exploring space, it's deciding how to share its stories responsibly. After all, nebulae belong to no one culture, but their meanings are deeply human. Whether as ancestral canoes or cosmic battlegrounds, they remind us that the universe is vast enough for countless stories, so long as we listen as much as we imagine. When Hubble's team released the first colorized image of the Eagle Nebula's pillars of creation, the public marveled at its ethereal beauty, but few realized how much artistic choice shaped that iconic vista. The decision to render oxygen as blue and sulfur as red wasn't arbitrary. It was a carefully crafted translation of invisible wavelengths into something our eyes could appreciate. Yet this process raises a thorny question. Where does scientific communication end and artistic interpretation begin? The debate erupted anew in 2019 when the Event Horizon Telescope unveiled the first image of a black hole. To highlight the accretion disk structure, researchers amplified certain contrasts, leading some critics to accuse them of cosmic Photoshop. But as Dr. Katie Bauman, a key figure in the project, countered, all data visualization involves choices. The challenge is making those choices honest. This tension between accuracy and accessibility isn't new. In the 1980s, NASA Voyager team faced backlash for enhancing Jupiter's colors to emphasize atmospheric bands, with purists arguing it misrepresented the planet's true appearance. Yet without these adjustments, many celestial wonders would look like grainy smudges to lay audiences. The Crab Nebula's intricate filaments, for instance, require false color mapping to reveal their chemical complexity. Astrophysicist Dr. Ethan Siegel defends the practice. We're not deceiving anyone, we're decoding. A nebula's true color doesn't exist because human vision can't perceive its full spectrum. Still, the line between clarification and distortion can blur. When the James Webb Telescope's team released its Carina Nebula image, the golden hues, while scientifically valid, were so strikingly different from Hubble's blues that some viewers assumed Webb had discovered a new nebula. This confusion highlights a growing need for transparency. Organizations like the International Astronomical Union now advocate for metadata storytelling, where images include clear annotations explaining color choices and processing steps. The European Space Agency even offers interactive tools letting users toggle between raw and enhanced views, demystifying the translation process. Artists face parallel dilemmas. Digital painter Lynette Cook meticulously bases her nebulae on telescope data, but admits to occasionally intensifying colors for emotional impact. Is it wrong to make the universe feel more alive? She asks, the answer may lie in intention. When sci-fi films depict nebulae as dense, ship-swallowing fog, they prioritize drama over facts, a harmless flourish in fiction, but problematic when documentaries mimic the approach. The key is context. NASA Pillars of Creation 3D model, though artistically smooth, explicitly labels its speculative elements, allowing viewers to distinguish observation from imagination. As we peer deeper into space with tools like the upcoming Nancy Grace Roman Telescope, these ethical considerations will only grow more pressing. Perhaps the solution isn't choosing between accuracy and artistry, but embracing their synergy. After all, Galileo sketched the moon's craters with both a scientist's precision and an artist's eye, proving that wonder and truth need not compete. The next frontier of cosmic representation won't just be about sharper images. It'll be about crafting a language of light that educates without misleading, inspires without exaggerating, and reminds us that the universe's greatest marvels need no embellishment. The next frontier of nebula exploration is already taking shape, and it promises to peel back even more layers of these cosmic enigmas. Slated for launch in 2027, the Nancy Grace Roman Space Telescope will wield a field of view 100 times wider than Hubble's, turning the slow, piecemeal study of nebulae into something closer to a panoramic survey. Imagine mapping the entire Orion Nebula in a single snapshot, capturing not just its towering pillars but the faint, wispy tendrils at its edges where stars are just beginning to coalesce. Dr. Jane Rigby, an astrophysicist working on the mission, describes it as going from examining individual brushstrokes to seeing the entire masterpiece at once. But Roman's real power lies in its infrared vision, which will pierce through dust clouds to expose the earliest stages of star formation regions so shrouded that even Webb can only glimpse them in fragments. Artificial intelligence is set to play a starring role in this new era, with telescopes generating more data than humans could possibly sift through. Machine learning algorithms are being trained to spot patterns invisible to the naked eye. At the University of Arizona, researchers have developed AI that can predict where protostars will emerge within a nebula by analyzing subtle ripples in gas density, like forecasting weather systems in a cosmic storm. Other projects like Google's DeepMind are transforming raw telescope data into dynamic 3D models, allowing scientists to walk through a nebula's structure in virtual reality. The line between discovery and immersion is blurring, says data visualization expert Dr. Kim Arkand. We're not just observing nebulae anymore, we're stepping inside them. Yet for all these advances, mysteries linger. One of the biggest revolves around dark matter's invisible hand. While we know nebulae are sculpted by gravity, new simulations suggest dark matter may warp their shapes in ways we're only beginning to detect. Dr. Priyamvada Natarajan, a Yale astrophysicist, points to oddities like the dark river in the Carina Nebula, a filament of gas that bends inexplicably as if tugged by an unseen force. If dark matter interacts with nebulae even fractionally, she notes, it could rewrite how we model star formation altogether. And how will artists respond to this flood of new cosmic detail? If history is any guide, they'll reinterpret it in ways that challenge and inspire. Digital creators are already experimenting with generative AI to produce nebula art that evolves in real time, mirroring the chaotic processes of star birth. Meanwhile, installations like TeamLab's Universe of Water in Tokyo let visitors manipulate projected nebulae with their movements, merging human creativity with astrophysical algorithms. The result is a feedback loop. Science fuels art, which in turn rekindles public fascination, driving support for the next big mission. As we stand on the brink of these discoveries, one thing is certain: the nebulae haven't given up their secrets yet. But with each new tool, we're not just uncovering answers, we're learning to ask better questions. Picture this: a group of astronauts floating in a zero-gravity studio aboard a Mars-bound spacecraft, their brushes trailing droplets of paint that hang suspended like tiny planets. This isn't science fiction, it's the next chapter in humanity's creative evolution. As we push toward interplanetary colonization, art won't just follow, it will transform, adapting to the rhythms of life beyond Earth. Already, initiatives like the International Space Station's Art in Space program hint at what's coming, with astronauts sketching Earth's curvature in real time and musicians composing melodies tuned to the hum of solar winds. But Mars will demand entirely new forms of expression. How do you capture the rust-colored vastness of a Martian sunset when your palette lacks Earth's blues and greens? What dances emerge when choreography must account for lower gravity? Pioneers like digital artist Nahum Romero are already experimenting, using VR to simulate Martian landscapes where brushstrokes behave differently and pigments interact with alien atmospheres. The very act of creation will become collaborative in ways we can barely imagine. Imagine deep space probes like Voyager, but instead of carrying golden records, they transmit real-time data streams of distant nebulae to orbiting artist collectives. These artists, part programmer, part painter, could use algorithms to translate cosmic radiation into immersive installations, with gallery-goers on Earth experiencing the pillars of creation as a multisensory storm of light and sound. Projects like ESA's Space in Bytes are laying the groundwork, turning satellite telemetry into generative art that evolves with solar flares. The line between astronaut and artist will blur as crews on lunar bases host residencies, their scientific observations doubling as poetic meditations. And what happens when nebulae aren't just distant wonders but landmarks for interstellar travelers? For future generations born on Mars or Europa, the Orion Nebula might become a cultural anchor, a glowing waypoint in their celestial mythology. Sci-fi author Kim Stanley Robinson envisions a future where colonies develop exo-folklore, with nebulae featuring in origin stories and rituals. Already, researchers at the SETI Institute are studying how spacefaring societies might encode knowledge in art, using nebula patterns as cosmic mnemonics. Educational programs will follow suit. Schools on Mars might teach physics through interactive holograms of star formation, while Earth-bound students attend virtual field trips to nebula nurseries, their lessons blending astrophysics with interstellar storytelling. The ripple effects could redefine creativity itself. Just as the Apollo missions inspired everything from disco aesthetics to environmental art, Mars colonization may birth movements we can't yet name. Perhaps red minimalism, using Martian soil pigments, or gravity ballet performed in orbital habitats. Museums won't just display art about space. They'll house pieces made in it, like sculptures forged from asteroid metals or films shot under the double shadows of Phobos and Deimos. This fusion of exploration and expression won't just document humanity's next giant leap. It will remind us that curiosity and creativity are the same force, the drive to reach beyond the known, whether with a telescope, a brush, or a rocket's flame. In a small classroom in New Mexico, middle school students aren't just learning about nebulae, they're painting them. With watercolors swirling across their papers, they debate whether to add more crimson to represent hydrogen or deepen the blues for oxygen, their teacher guiding them through the real chemistry behind their artwork. This is Astro Art, a growing movement in STEM education that uses the beauty of nebulae to bridge the gap between science and creativity. Programs like NAS, a universe of learning, provide teachers with telescope data and lesson plans, turning raw cosmic images into collaborative projects where students decode color maps to reconstruct the pillars of creation. The result, test scores in astrophysics concepts have jumped by nearly 40% in participating schools, proving that when science wears the cloak of art, it doesn't just educate, it captivates. Planetariums are embracing this fusion too. At Chicago's Adler Planetarium, visitors don't just gaze at nebula projections, they manipulate them. Interactive exhibits let kids sculpt virtual gas clouds with hand gestures, watching how gravity and radiation shape their creations in real time. Director of Education Dr. Lindsay Coran calls it science through play, noting that families linger 3 times longer at these stations than traditional displays. Meanwhile, institutions like the European Space Agency host nebula hackathons, where teens use open-source telescope data to code their own animated star-forming regions, blending programming, physics, and digital art into one immersive experience. The success stories are as diverse as the nebulae themselves. In rural India, where telescopes are scarce, educators use smartphone apps that overlay augmented reality nebulae onto schoolyard skies, letting students zoom in on Orion's swirling gases with a tap. In Sweden, a visually impaired student developed a tactile model of the Crab Nebula using 3D printed filaments, her fingers tracing the same shockwaves astronomers study. These aren't just teaching tools, they're testaments to how cosmic phenomena can unlock creativity in unexpected ways. Yet the potential goes beyond classrooms. Amateur astronomers and artists are collaborating like never before, with platforms like Zooniverse inviting the public to classify real nebula images from professional telescopes. Citizen scientist Hanny van Arkel famously discovered Hanny's voorwerp, a mysterious green gas cloud, while reviewing Hubble data as part of an online project. Now, similar initiatives encourage participants to sketch their interpretations, with the best artworks featured in museum exhibitions alongside the science that inspired them. This grassroots movement proves something profound. You don't need a PhD to contribute to our understanding of the cosmos, just curiosity and perhaps a paintbrush. Advocates argue this art-science hybrid should be foundational, not optional. Why force students to choose between equations and expression when the universe itself doesn't? Asks Dr. Jorge Morno, a physicist who co-developed a high school curriculum pairing nebula photography with poetry. His studies show that students in integrated programs are twice as likely to pursue STEM careers, especially girls and underrepresented minorities. The message is clear. Nebulae aren't just teaching us about stars, they're teaching us how to teach by reminding us that wonder is the most powerful motivator of all. And in that alchemy of color, data, and imagination, we're not just educating future scientists, we're nurturing future storytellers of the cosmos. Imagine logging onto your laptop after dinner, clicking open a telescope feed from Chile's Atacama Desert, and spotting a never-before-seen tendril of gas curling through the Orion Nebula. This isn't science fiction, it's the everyday reality for thousands of amateur astronomers on platforms like Zooniverse, where anyone with curiosity can contribute to groundbreaking discoveries. Take the story of Dutch schoolteacher Hanny van Arkel, who in 2008 stumbled upon a bizarre green cloud near a distant galaxy while classifying images for the Galaxy Zoo project. Dubbed Hanny's voorwerp, Dutch for Hanny's object, this cosmic oddball turned out to be a luminous echo of a quasar outburst, a phenomenon so rare it spawned over a dozen scientific papers. What's remarkable isn't just that an amateur found it, but how, by noticing something that algorithms and professionals had overlooked, the human brain excels at pattern recognition, explains Dr. Laura Truill, Zooniverse's lead researcher. Volunteers spot anomalies because they aren't trained to ignore the unexpected. The scale of these collaborations is staggering. Projects like a Disk Detective have enlisted over 30,000 volunteers to sift through NASA's telescope data, identifying protoplanetary disks where planets might form. In Australia, the Stargazing Live initiative once marshaled 40,000 viewers to scan infrared surveys, leading to the discovery of 4 new nebula structures in a single week. These efforts aren't just busy work, they're filling critical gaps. professional astronomers, drowning in petabytes of data from telescopes like Vera Rubin and JWST, rely on citizen scientists to flag the needles in cosmic haystacks. As Dr. Brooke Simmons, an astrophysicist working with Zooniverse, puts it, every time someone clicks classify, they're extending science's reach beyond the walls of universities. But the impact goes deeper than cataloging gas clouds. Platforms like Backyard Worlds invite users to hunt for brown dwarfs, failed stars lurking near our solar system, using tools simple enough for a middle schooler. One participant, 46-year-old graphic designer Rosa Castro, discovered a previously unknown brown dwarf while reviewing images during her lunch break. "I kept thinking this speck looks odd," she recalls. "That speck turned out to be a cosmic fossil, colder than most known stars and brimming with clues about stellar evolution." Stories like Rosa's shatter the myth that space exploration belongs only to elites with PhDs. With free apps like NASA, Nebula Snap, even smartphone users can analyze Hubble images, tagging structures for researchers halfway across the globe. This democratization of discovery raises profound questions about how we define expertise. When a retired mechanic in Brazil identifies a jet of ionized gas in the Orion Nebula, or a high school student in Kenya maps dust lanes in the Eagle Nebula using public data, the boundary between scientist and enthusiast blurs. Philosopher Dr. Alice Roberts argues that citizen science taps into something primal. We're all descendants of cultures that navigated by stars and told stories about constellations. Crowdsourcing astronomy isn't new, it's a return to our collective roots. Perhaps the most stirring lesson lies in what these nebulae reveal about human curiosity. The same cosmic clouds that inspired Galileo's sketches and Van Gogh's swirls now inspire millions to log on and explore. Every annotated image, every tagged protostar, becomes part of a vast collaborative artwork, one where the canvas is the cosmos itself. So the next time you gaze at a photo of the Orion Nebula, remember, you're not just looking at stars being born, you're looking at a mirror reflecting our timeless urge to reach beyond the known, one click at a time. Standing beneath a sky streaked with the faint glow of a distant nebula, it's hard not to feel a peculiar duality, a simultaneous sense of insignificance and profound connection. Carl Sagan captured this tension perfectly when he described Earth as a pale blue dot, a speck suspended in a sunbeam, dwarfed by the cosmic vastness. Yet within that vastness, nebulae serve as both humbling reminders and astonishing revelations. Their sheer scale spanning light years, birthing stars over millennia, reduces human lifespans to the blink of an eye. But here's the paradox: those same swirling clouds of gas are the very reason we exist. The iron in our blood, the calcium in our bones, every atom heavier than hydrogen was forged in the heart of a star and scattered across the cosmos by nebulae. We are quite literally stardust contemplating itself. Modern philosophers like Nick Bostrom and existentialist writers grapple with this duality. On one hand, the universe's immensity can evoke existential dread. What meaning can our brief lives hold in the face of such infinity? On the other, nebulae offer a counterpoint. They are proof that chaos gives rise to order, that destruction fuels creation. The Crab Nebula, the remnants of a supernova witnessed 1,000 years ago, isn't just a graveyard. It's a nursery recycling stellar debris into new planets, new life. This cyclical nature mirrors human resilience, our ability to find purpose even in impermanence. As philosopher Alan Watts once observed, "You are the universe experiencing itself." Nebulae, in their relentless creativity, embody that idea. This cosmic perspective reshapes how we view our responsibilities. If Earth is a fragile oasis in the void, then nebulae are both cautionary tales and blueprints. Take the delicate balance of the Orion Nebula's pillars, gravity sculpting gas into stars, but too much radiation or too little material, and the process collapses. It's a celestial metaphor for environmental stewardship. Climate scientist Katharine Hayhoe often draws parallels between nebulae and Earth's ecosystems, noting how both rely on precarious equilibriums. Just as a nebula's chemistry must align to birth stars, our atmosphere's balance allows life to flourish. The difference: nebulae operate on cosmic timescales. Our planet's fate hinges on human choices made in mere decades. Artists and activists alike are harnessing this metaphor. Installations like Olafur Eliasson's Earth Perspectives project nebula imagery onto glaciers, merging cosmic and terrestrial fragility. Meanwhile, poets like Ocean Vuong write of nebulae as the universe's breath, urging readers to see Earth's atmosphere as equally sacred. Even space agencies frame missions through this lens. ESA's Gaia telescope maps the Milky Way with the same precision ecologists used to track deforestation, underscoring that understanding the cosmos and preserving our planet are two sides of the same coin. Perhaps the ultimate lesson lies in the way nebulae defy simplicity. They are neither purely destructive nor purely creative, neither wholly alien nor entirely familiar. They remind us that meaning isn't found in grand cosmic answers, but in the act of questioning itself. Every time we gaze at a Hubble image or ponder Sagan's words, we're participating in something timeless, a conversation between stardust and curiosity, spanning billions of years. And in that dialogue, nebulae offer not just awe, but an invitation to cherish our fleeting moment in the universe's story, and to leave it richer than we found it. Stretching across light years, the delicate tendrils of a nebula glow with an almost ethereal fragility, their structures so finely balanced that the slightest disturbance can reshape them for millennia. It's a cosmic dance of creation and vulnerability, one that mirrors the delicate equilibriums we find here on Earth. Consider the pillars of creation, those towering columns of gas in the Eagle Nebula. They're sculpted by the very stars they birth, stellar winds carving cavities, radiation eroding their edges. Yet without that careful interplay of forces, the pillars would collapse and star formation would stall. It's a poignant parallel to our planet's ecosystems, where rainforests, coral reefs, and atmospheric layers exist in similarly precarious harmony. Climate activist Dr. Ayanna Elizabeth Johnson often invokes this connection, noting how nebulae teach us that resilience isn't about brute strength, but about interdependence. This cosmic metaphor has sparked a wave of environmental campaigns that harness the beauty of nebulae to galvanize action. Organizations like NAS, a Climate Kids program, overlay Hubble images of nebulae with time lapses of melting glaciers, framing Earth's climate crisis as a disruption of celestial scale balance. Artist collective, The Cosmic Bridge, projects nebula visuals onto deforestation maps, their swirling hues highlighting the stark contrast between nature's artistry and human impact. Even Greta Thunberg's Fridays for Future movement has adopted nebula motifs in their visuals, with banners declaring, "If nebulae can nurture stars across millennia, why can't we protect our home for a single generation?" The message is clear: the same forces that shape the cosmos also govern our survival. But the power of these celestial metaphors extends beyond activism, it's seeping into therapy and mental health. Psychologists are increasingly using nebula imagery in mindfulness practices, guiding patients to meditate on the interplay of chaos and order in star-forming regions. Dr. Maria Esposito, a clinical psychologist specializing in eco-anxiety, developed a technique called cosmic grounding, where patients visualize their stressors as turbulent nebula clouds slowly settling into stable patterns. There's something profoundly calming about realizing your struggles mirror the universe's own cycles of disruption and renewal, she explains. Apps like Stellar Mind now offer nebula-based breathing exercises. Their pulse points sync to the rhythmic flicker of protostars in the Orion Nebula. Perhaps the most unexpected application lies in hospice care, where terminal patients are given virtual reality journeys through nebulae like the Helix or Ring. Nurse Lillian Choi recalls one patient who, after a VR session floating through the Carina Nebula, whispered, "Now I understand, I'm not ending, I'm just scattering like stardust." In these moments, nebulae become more than scientific phenomena or artistic muses. They're bridges between the microscopic and the cosmic, between human frailty and universal resilience. They remind us that fragility isn't weakness, it's the necessary condition for transformation, whether in the heart of a gas cloud or the soul of a person. And in that shared vulnerability, we find our deepest connection to the cosmos. Walking into the dimly lit therapy room at Boston Children's Hospital, you'd expect stark white walls or soothing pastels, but instead, the ceiling blooms with the swirling blues and golds of the Orion Nebula. This isn't just decoration, it's medicine. Doctors here have pioneered using real Hubble images as therapeutic tools, projecting nebula visuals above patients during painful procedures. The results, a 23% drop in reported pain levels and a dramatic reduction in stress hormones. The fractal patterns in nebulae, those repeating, self-similar shapes, trigger a relaxation response in the brain, explains neurologist Dr. Rachel Kim. It's like visual white noise, giving the mind a focal point that's complex enough to distract but orderly enough to calm. Studies from the University of Oregon back this up, showing that viewing fractal-rich nebula art lowers blood pressure and slows racing thoughts as effectively as guided meditation. Artists are collaborating with neuroscientists to amplify this effect. Digital creator Matteo Sanche crafts interactive nebula installations for burn units, where patients paint virtual gas clouds with hand movements, their gestures altering the projected colors in real time. The more control they feel over the chaos, the less overwhelming their pain becomes, Sanche observes. One teenage patient recovering from third-degree burns described the experience as floating through space instead of being trapped in my body. Meanwhile, apps like Nebula Flow use generative AI to tailor fractal visuals to individual brainwave patterns, syncing with biofeedback sensors to deepen relaxation. The commercial world is catching on. From corporate offices to airport lounges, dynamic nebula projections are replacing static art, their ever-shifting hues proven to reduce employee stress by 31% in a Yale-funded study. Even home wellness brands are jumping in the Stellaris meditation lamp, which mimics the pulsating glow of the Crab Nebula, sold out within hours of its launch. But beyond trends, there's a profound cultural shift at work. We're relearning what ancient cultures always knew. The Navajo used star maps for healing ceremonies, and Maori healers invoked the Magellanic Clouds during childbirth. Modern science is just giving us new language for an old truth, that gazing at the cosmos doesn't just expand our understanding of the universe, it heals our place within it. Runway lights dim as a model strides forward, her gown alive with swirling blues and violets that shift like the Orion Nebula under black light. This isn't just fashion, it's astrophysics in motion. Designers from Paris to Tokyo are turning to telescope data for inspiration, using Hubble's palette of cosmic hues to craft collections that blur the line between couture and cosmology. Iris van Herpen's 2023 Celestial Couture line employed 3D printed fabrics mimicking nebula filaments, while Louis Vuitton's Stellar Voyage accessories embedded micro-encapsulated pigments that change color under UV light, replicating the eerie glow of ionized hydrogen. "We're not just borrowing colors," explains textile artist Dr. Nelini Maloni, who collaborates with NASA scientists. "We're encoding the physics of star formation into wearable art. Each pleat represents a shockwave, every sequin a newborn star." This cosmic trend extends beyond the catwalk. Home decor brands like Cosmic Threads handprint nebula patterns onto organic cotton throws using dyes derived from meteorite minerals, while lighting company Luminora sells chandeliers that project real Hubble images across ceilings. Even corporate branding has caught the celestial bug. Spotify's Equalizer Nebula campaign transformed user listening data into personalized gas cloud visuals, and Tesla's Cybertruck reveal featured a backdrop mimicking the Veil Nebula's tangled remnants. But with this boom comes ethical dilemmas. When fast fashion retailers mass-produce nebula print dresses for pennies, often lifting designs directly from copyrighted telescope images without crediting scientists, it raises questions about who owns the cosmos. Indigenous communities like the Maori have long protested the commercialization of star lore, while astrophotographers like Alyssa Goodman warn of cosmic plagiarism, where their painstakingly processed images become corporate clip art. The challenge intensifies when preserving these designs for posterity. Unlike traditional textiles, nebula-inspired creations often rely on reactive dyes, electroluminescent threads, and other ephemeral technologies. The Victoria and Albert Museum's conservation team recently struggled to stabilize a Van Herpen nebula gown whose photochromatic panels degraded after just 5 years. "We're essentially preserving starlight," sighs curator Dr. Emily Roy. "These materials fade as unpredictably as the real nebulae they mimic." Some designers are turning to blockchain, embedding digital twins of their cosmic collections as NFTs linked to telescope archives, a controversial solution that at least ensures the science behind the art isn't lost. Perhaps the most poignant iteration appears in adaptive fashion. Brands like Chromatic Threads design sensory-friendly nebula patterns for neurodivergent wearers, using gradient transitions clinically proven to reduce anxiety. One mother describes her autistic daughter's reaction to a Carina Nebula-inspired dress. She calls it her quiet space, tracing the fabric's swirls like they're a tactile star map. In these moments, the cosmic and the deeply personal collide, proving that when humanity gazes at nebulae, we don't just see distant clouds. We see canvases for our collective dreams, stitched together across light years and loom. Every image of a nebula we marvel at today, from Hubble's iconic pillars of creation to Webb's golden vistas of the Carina Nebula, represents more than a scientific snapshot. These are cosmic heirlooms meticulously preserved for future generations. But how do you archive something as vast and dynamic as a stellar nursery? The answer lies in a blend of cutting-edge technology and old-world craftsmanship. At the European Space Agency's Cosmic Archives in Madrid, petabytes of telescope data are etched onto ultra-stable sapphire disks, each capable of surviving for millions of years without degradation. It's a modern twist on ancient cave paintings, humanity's urge to leave a permanent record of the wonders we've witnessed. "We're not just storing data," says Dr. Elena Morty, head of the archive. "We're fossilizing light itself." Yet digital storage is only part of the story. In a quiet corner of the Library of Congress, you'll find a leather-bound volume containing hand-drawn plates of the Orion Nebula, sketched by astronomer Etienne Trouvelot in 1875. His pastel renderings, delicate as they are, have outlasted early digital formats like floppy disks and magnetic tape. This paradox underscores a surprising truth. sometimes the best way to future-proof cosmic beauty is to marry the ultra-modern with the timeless. Projects like NASA Nebula Codex take this literally, translating Hubble's raw data into laser-etched metal plates, a format that could endure even if civilization reboots. The challenges are as immense as the nebulae themselves. A single observation from the James Webb Telescope can generate terabytes of data, requiring algorithms to identify and preserve only the most scientifically significant frames. Machine learning now helps archivists tag cosmic moments, like the precise instant a protostar's jets pierce through a gas cloud, ensuring future researchers don't drown in data while searching for needles in a celestial haystack. Meanwhile, citizen science initiatives like Nebula Rescue crowdsource the recovery of decaying analog observations, digitizing glass plate negatives from 19th century observatories before their silver emulsion fades into oblivion. But for all our efforts, some mysteries resist preservation. Take the Red Rectangle Nebula, whose bizarre geometric patterns defy current astrophysical models. Or the Green Pea Galaxy's tiny, intensely star-forming regions that shouldn't exist according to conventional theories. These enigmas remind us that no archive, no matter how vast, can capture the full story. The universe keeps its secrets close, revealing just enough to keep us reaching further. As we store these cosmic portraits for posterity, we're not just saving data. We're bottling the very essence of human curiosity, the relentless drive to ask, what's out there? And perhaps that's the most enduring artifact of all. Even with all our telescopes and supercomputers, nebulae still guard some of their most fundamental secrets. Take the Tarantula Nebula, a sprawling stellar factory in the Large Magellanic Cloud where stars form at a frenetic pace, 10 times faster than in our own Orion Nebula. Why astronomers have spent decades chasing answers, and the clues they've uncovered only deepen the mystery. Some point to the tarantula's extreme density, where gas piles up like interstellar traffic jams, collapsing into stars almost as soon as it gathers. Others suspect hidden forces at play, perhaps magnetic fields, those invisible cosmic puppet strings, channeling gas into star-forming streams with eerie precision. Then there's the wild card theory, external triggers. When a nearby star explodes as a supernova, its shockwaves can slam into a nebula like a cosmic hammer, crushing gas clouds and jump-starting stellar births. Evidence for this lingers in nebulous structures, where telltale ripples and bubbles hint at ancient stellar violence, but the plot thickens when you compare nebulae across galaxies. In the Whirlpool Galaxy's glowing arms, nebulae blaze with newborn stars, while in the Sombrero Galaxy's dust lanes, they seem strangely dormant. Could galactic environment be the key? Teams using the ALMA telescope recently discovered that nebulae in crowded galactic cores face constant turbulence, gas torn by passing stars, stirred by black hole winds, creating conditions too chaotic for orderly star formation. Yet in isolated dwarf galaxies, where nebulae drift in serene solitude, stars emerge at a leisurely pace. It's as if the universe has multiple blueprints for creation, each dependent on a nebula's cosmic neighborhood. The most tantalizing questions revolve around dark matter's ghostly influence. In the Dragonfly Nebula, astronomers have detected filaments of gas bending in ways gravity alone can't explain, almost as if unseen hands are sculpting the chaos. Simulations now suggest dark matter might act like a cosmic sponge, soaking up stray energy and allowing gas to cool faster, accelerating star birth. If proven, this would rewrite our understanding of how nebulae evolve, placing an invisible architect at the heart of stellar nurseries. These puzzles demand more than just bigger telescopes, they require fresh perspectives. Enter the interdisciplinary rebels, plasma physicists collaborating with jazz musicians to model nebula turbulence as sound waves, or AI researchers training neural networks on Renaissance paintings to decode the fractal patterns in star-forming clouds. At MIT's Space Exploration Initiative, engineers 3D print nebula structures using ferrofluids, revealing how magnetic fields might braid interstellar gas. Meanwhile, poets and astrophysicists co-write Cosmic Hakis for the Vera Rubin Observatory's data logs, proving that sometimes the right metaphor can spark the right equation. What's clear is that nebulae refuse to be boxed into a single discipline. They're astrophysical objects, yes, but also artistic muses, philosophical prompts, and catalysts for innovation. The next breakthrough might come from a sculptor studying how clay collapses under its own weight, or a game designer coding nebula physics into a virtual universe. After all, the greatest cosmic mysteries rarely yield to brute force alone. They surrender to curiosity in all its wild, interdisciplinary forms. So here's an invitation. The next time you gaze at a nebula image, let it unsettle you. Wonder not just about how stars are born, but how we might birth new ways of seeing. The answers, like the nebulae themselves, are still taking shape. The most groundbreaking discoveries often emerge when two seemingly unrelated fields collide, and nowhere is this more evident than in the collaborations between artists and astrophysicists. Take NASA Golden Record, launched aboard the Voyager probes in 1977. At first glance, it was a time capsule of human culture, music, greetings, and images etched onto a gold-plated copper disc. But the team behind it wasn't just scientists. It included avant-garde composers like Laurie Spiegel and artists like John Lomerg, who translated planetary data into musical scales and encoded brainwave patterns into sound. The result wasn't merely a message to aliens, it was a radical experiment in how art could distill complex science into something universal. When Spiegel transformed the orbital rhythms of planets into a haunting electronic composition, she didn't just create music, she revealed a hidden harmony in celestial mechanics that equations alone couldn't convey. This synergy has only deepened with time. At CERN, the European Particle Physics Lab, artists in residence like Giulietta Aranda work alongside physicists, using subatomic collision data to generate immersive installations. One project, Quantum Chromodynamics, visualized quark interactions as pulsating light fields, a piece that later inspired physicists to rethink how they modeled particle spin. Artists ask questions scientists don't, explains Dr. James Beecham, a CERN physicist. They'll see a data plot and wonder, what does this sound like? How would it feel to touch? Those seemingly whimsical queries often lead us to new analytical tools. The limits of human perception loom large in these partnerships. Our eyes see less than 1% of the electromagnetic spectrum, and our brains struggle to grasp scales beyond everyday experience. That's where artists step in. When Dr. Andrea Ghez needed to explain her Nobel-winning work on the Milky Way's supermassive black hole, she turned to virtual reality artist Eliza McNitt. Together, they built Black Hole Symphony, an experience that lets users hear the black hole's gravity warping space-time into musical chords. The piece didn't just popularize science, it gave even seasoned astronomers an intuitive grasp of relativistic effects that equations rendered abstract. Yet these collaborations aren't without friction. Purists in both fields sometimes bristle at the compromises required. Astrophotographers debate whether enhancing nebula colors for public outreach betrays scientific accuracy, while artists chafe when asked to simplify concepts for accessibility. The tension mirrors a deeper question. How do we translate truths that defy human senses? A nebula's magnetic fields, for instance, are invisible to us, yet they sculpt star-forming regions as surely as wind-shaped sand dunes. Teams like the Art Science Collective at Imagery tackle this by creating data sculptures, tangible models where 3D printed filaments represent magnetic lines, letting fingers trace what eyes cannot see. Perhaps the most profound lesson lies in humility. For all our technology, we're still creatures bound by biology, interpreting the cosmos through the narrow window of our senses. When a painter renders the ultraviolet glow of a young star cluster in hues our eyes can process, or a musician sonifies the radio whispers of a pulsar, they're not just translating science, they're expanding the very definition of observation. In the end, these partnerships remind us that understanding the universe isn't just about collecting data. It's about learning to see, hear, and feel in ways we haven't yet imagined. Imagine closing your eyes and hearing the pillars of creation, not as an image, but as a symphony of deep cello notes for dense gas clouds, chimes for newborn stars, and a low hum echoing the relentless pull of gravity. This isn't fantasy, it's the heart of projects like Cosmic Vibrations, where astrophysicists and musicians collaborate to sonify nebula data, transforming light wavelengths into melodies. For visually impaired scientist Dr. Wanda D.S. Merced, who lost her sight in her 20s, these auditory maps aren't just accessibility tools, they're revelation. When I listen to the Crab Nebula's gamma ray bursts as pulsating rhythms, she explains, I detect patterns sighted colleagues miss in visual graphs. Her groundbreaking work proves that cosmic beauty isn't bound to vision alone. Museums worldwide are embracing this multisensory shift. London's Royal Observatory now offers tactile 3D printed nebula models, their surfaces etched with braille annotations describing chemical compositions. Visitors trace the Horsehead Nebula's silhouette with their fingertips, feeling where hydrogen ridges give way to the smoother contours of dust lanes. Meanwhile, the Smithsonian's Universe in Sound exhibit lets attendees play the Orion Nebula on a floor-sized audio grid, stepping on pressure pads to trigger sounds corresponding to different gas densities. It's not metaphor, says designer Elijah Peterson. You're literally walking through a star-forming region, your footsteps composing the nebula's song. But inclusivity in cosmic storytelling goes beyond exhibits. Apps like Astro Access translate real-time telescope data into haptic feedback, allowing blind astronomers to feel a nebula's structure through vibrating gloves. A gentle pulse might denote a protostar, while rapid tremors signal turbulent stellar winds. Teenage programmer Rachel Patel, who developed the app after her brother lost his sight, describes watching him gasp as he traced the Veil Nebula's shockwaves. He said it was like holding a thunderstorm in his hands. These innovations hint at a future where space exploration engages all senses. Picture VR suits that let you swim through nebula gases, your body registering temperature shifts as you approach young stars, or scent diffusers releasing the faint, metallic tang of ionized oxygen, an olfactory nod to the elements brewing in these cosmic cauldrons. Artists like Tavers Strachan are already prototyping interstellar perfume, distilling the hypothetical smells of distant nebulae based on their chemical signatures. The implications stretch far beyond Earth. As we plan for Mars colonies and deep space habitats, designing inclusive ways to experience the cosmos becomes existential. If a child born on Mars can't see Earth's sky, how do we share the wonder of nebulae? Projects like Cosmic Weave offer one answer: smart fabrics embedded with pressure-sensitive threads that mimic nebula densities when touched, turning blankets into portable star nurseries. Ultimately, these multisensory experiments reveal a profound truth: nebulae aren't just visual spectacles. They're vibrational, textural, even olfactory landscapes waiting to be explored. By decoupling cosmic wonder from the tyranny of sight, we're not just making astronomy accessible, we're rediscovering it. Picture this, the year 2124, and your morning commute isn't to an office, it's to the heart of the Orion Nebula. Strapping on a neural headset, you step into a hyper-realistic simulation where every wisp of ionized gas brushes against your virtual skin with scientifically precise pressure, and the thunderous roar of stellar winds vibrates through your bones. This isn't just VR, it's cosmic teleportation, a blend of quantum computing and real-time telescope data so advanced it tricks your brain into believing you're floating light years from home. Tourists might flock to the Pillars of Creation experience, where they can watch protostars ignite in immersive 3D, while students dissect nebula chemistry with gesture-controlled holograms. But beneath the wonder lies a thorny question: when we can simulate, or perhaps even reach, these cosmic cradles, do they remain wilderness or become another commodity? The ethical dilemmas multiply if warp drives ever transition from sci-fi to reality. Imagine mining corporations eyeing the Tarantula Nebula's rich reservoirs of hydrogen and helium-3, or luxury hotels orbiting the Rosette Nebula, their windows framing stellar nurseries like safari lodges overlooking a watering hole. Would nebula preservation zones emerge, akin to Earth's national parks? Legal scholars are already debating celestial conservation models where certain nebulae are designated UNESCO-style heritage sites, off-limits to industrial exploitation. Indigenous groups like the Maori, who view the Magellanic Clouds as ancestral vessels, could lead the charge to protect nebulae from cultural appropriation. After all, if a mining laser alters the gravitational balance of a star-forming region, does that constitute cosmic vandalism or just progress? Cultural shifts would ripple across generations. For children born in a world where nebulae are travel destinations, these cosmic clouds might lose their mystique, becoming as familiar as mountain ranges. Yet artists and poets could rebel, crafting movements that re-sacralize the unexplored. Picture neo-Luddite colonies on Mars, where telescopic observation replaces simulation, or underground analog astronomy clubs where members stargaze through vintage refractors to recapture the awe of pre-digital discovery. Meanwhile, religions might reinterpret nebulae as divine workshops, their star-forming chaos seen as evidence of a hands-on creator. The Vatican's 22nd century observatory could release encyclicals on the theological implications of artificial nebula manipulation. Now turn the lens inward. If you could stand in the shadow of the Eagle Nebula's pillars, watching stars being born in real time, how would it reshape your sense of scale or mortality? Astronomer Carl Sagan once called Earth a mote of dust suspended in a sunbeam. But what happens when that mote's inhabitants can touch the sunbeam's source? The paradox is haunting. The more accessible the cosmos becomes, the more it might shrink in our imaginations. Yet perhaps that's the ultimate challenge nebulae present, not just to explore them, but to preserve their power to humble us. After all, their beauty has always lain not just in their light, but in their distance, their unreachability. The moment we bridge that gap, we'll face a choice: conquer the cosmos or let it continue to conquer us. Now it's your turn to join the cosmic conversation. Grab a sketchbook, a camera, or even just your phone, because the beauty of nebulae isn't just something to admire, it's something to reinterpret, to make your own. Think of the Orion Nebula not as a distant cloud of gas, but as a blank canvas waiting for your perspective. You don't need a telescope to capture its essence. Start simple, step outside on a clear night and let your eyes adjust. even the faintest smudge of light like the Andromeda Galaxy, visible to the naked eye, can spark inspiration. Sketch what you see not as an exact replica, but as an emotional response. Maybe those swirling strokes of charcoal become the turbulence of stellar winds, or the smudged pastels echo the soft glow of ionized hydrogen. There's no wrong way to create. Every interpretation adds to the tapestry of how we understand these cosmic wonders. For those drawn to photography, astrophotography might seem daunting, but it's more accessible than ever. A basic DSLR camera, a sturdy tripod, and a dark sky are all you need to begin. Set your camera to manual mode, open the aperture wide, and experiment with long exposures. Start with 15 seconds to avoid star trails. Even without tracking mounts, you can capture the Milky Way's grandeur or the delicate haze of the Pleiades. Free apps like Stellarium help locate nebulae, while editing tools like Sequator stack multiple shots to reduce noise, revealing hidden details. The key isn't technical perfection, it's patience and curiosity. Some of the most evocative astrophotography comes from embracing imperfections, like the slight blur of a passing satellite, or the way light pollution paints the sky an unexpected shade of amber. Writers and poets, too, can channel nebulae into their work. Consider the way a nebula's light travels centuries to reach us, or how its elements will one day become part of new worlds. Turn those ideas into metaphors for resilience, for transformation. Science fiction writers might imagine civilizations born in the shadow of the Carina Nebula, their myths woven around its towering cliffs of gas. Or perhaps a haiku captures the stillness of watching the night sky, where every line holds the weight of light years. The goal isn't to mimic what's already been said, but to find your own voice in the vastness. And if you're feeling adventurous, blend mediums. Create a digital collage pairing your smartphone shots of twilight clouds with Hubble's palette of cosmic colors. Compose a melody using sonified data from the James Webb Telescope, translating infrared wavelengths into music. The boundaries between art and science are as fluid as the nebulae themselves, so don't hesitate to cross them. When you're done, share your creations, tag them with #mycosmicstory, and you might just inspire someone else to look up, because the magic of nebulae isn't just in their light, but in the way they remind us that creativity, like starlight, travels endlessly. Your unique perspective, whether it's a shaky first astrophotography attempt, a poem scrawled at midnight, or a child's finger-painted galaxy, adds another thread to the universe's grand narrative. So go ahead, let the cosmos be your muse. Who knows what wonders you'll uncover when you dare to see the universe not just as it is, but as it could be. From the moment ancient stargazers wove myths about glowing celestial clouds to today's cutting-edge telescopes revealing the physics of star birth, nebulae have always been more than just cosmic phenomena. They're bridges. Bridges between calculation and wonder, between what we can measure and what we can feel. Science gives us the equations to understand how gravity sculpts these swirling clouds of gas, while art translates that knowledge into something visceral, a symphony, a painting, a poem that makes the universe's grandeur personal. Together, these twin lenses show us that to truly grasp the cosmos, we need both the precision of a physicist and the imagination of a poet. Think of the Hubble Space Telescope's iconic images, those vibrant portraits of the pillars of creation or the Helix Nebula's eerie eye. Scientists pore over them to decode stellar evolution, tracing the life cycles of stars hidden within. Yet those same images have hung in dorm rooms and art galleries, inspiring musicians to compose orchestral suites and tattoo artists to ink cosmic masterpieces on skin. The data doesn't lose its truth when it becomes art, it gains resonance. A child who sees Van Gogh's Starry Night might grow up to study astrophysics, while a researcher analyzing the Crab Nebula's shockwaves might pause to marvel at its haunting beauty. Curiosity and creativity aren't opposites, they're companions on the same journey. This duality echoes in how we share these discoveries. When the James Webb Telescope beams back its golden-hued vistas, astronomers don't just publish papers. They collaborate with digital artists to turn raw data into immersive experiences. Virtual reality lets us stand inside a nebula, while sonification projects transform radio waves into melodies. These aren't gimmicks, they're proof that understanding deepens when we engage more than just our intellect. A tactile model of the Orion Nebula, its 3D printed ridges mapping gas densities, can reveal patterns a graph might obscure. The universe speaks in infinite dialects, and the more ways we learn to listen, the richer the conversation becomes. Nebulae remind us that exploration isn't just about collecting facts, it's about forging connections. The hydrogen in these glowing clouds will one day fuel new stars, new planets, perhaps even new life. The iron in your blood, the calcium in your bones, they were forged in stellar furnaces and scattered across space by nebulae long gone. As Neil deGrasse Tyson so perfectly put it, we are not just in the universe is in us. That's the true magic of these cosmic nurseries. They're not just out there, they're part of us, threads in a story that stretches from the Big Bang to this very moment. So here's your invitation. Look up, sketch what you see, share it. Whether it's a shaky smartphone photo of the Milky Way, a doodle of the Orion Nebula, or a story about the night sky that moved you, your perspective adds to this grand collective tapestry. Drop your nebula stories in the comments below, and don't forget to subscribe for more journeys to the stars, because the universe isn't just something we observe. It's something we create together.